Hi everyone, I think we should get started. Can everyone hear me? Is the sound fine? Just send a message, just a thumbs up if you can hear me properly, please, just so that I know. Hi. Okay, we are going to do grade 12 finance today. Thanks, Abby. Alright, we're going to do grade 12 finance today, and I thought that we would just work through some NSC past paper exam questions. That's usually a good way of figuring out especially how many marks you can get for the finance section. I'll also show you the mark allocation so that you can see what you would actually get marks for. So before we actually start, let's just look at some formulas, because in finance the formulas are very important. Obviously you will get the actual formula sheet. Let me just write here finance formulae. Thank you, I'm glad. Alright, so the finance formulae that you will get on the formula sheet, but you do need to know which formula is for what kind of thing. They're not going to tell you this is a future value formula, this is the present value formula. They're going to just give you the formulas on the formula sheet, and you need to identify the one that you're going to use. So for annuities, there are two formulas that you can find on the formula sheet. Now, an annuity is when you are making regular payments. So for example, monthly payments. Another way in which they ask it quite often is quarterly payments, which is 4 times a year. So you'll make a payment every 3 months. But that is an annuity. An annuity and the annuity formulas you will only use if you are making regular payments. So there are two types. Sorry that the focus goes out every time I'm writing. There are two types of annuities. So you're going to do the future value one. And the formula is X. Then you have in your brackets 1 plus I to the power of n minus 1. And then that is all over I. Now we are going to practice these formulas as well, but just a quick rundown. The future value and this formula specifically is for when you are saving up, you're making regular payments for an actual value that you want at some point in the future. So a nice real life example is when you have a pension fund, for example. An amount goes into the pension fund every month, and that is to save up to have a certain amount, well, not necessarily a certain amount of money, but to have money at some point in the future. So for that, you'll use the future value formula. The F, the future value, is then what you end up with at the end of the time period. X is going to be the regular payments that you're making. So the monthly payment, the quarterly payment, the biannual, as in twice a year payment, whatever that payment is, that will be X. Then in your formula, I appears twice. That is the interest rate. We're going to talk about how to write your interest rate in the easiest way. And then N is the number of payments, not necessarily the number of years. N is the number of payments. So that's also important that we work with that. Then the present value formula is the one that starts with P on the formula sheet, so it's easy to identify. F is for future value, so where you're saving up for an amount in the future. P is the present value formula, which is what you, mostly when you're working with a loan. So the present value is then, you know, when you take out a loan for like R1 million, you get that R1 million at present. Immediately you receive that money. It's not like you are paying, and after like 10 years you're going to receive that R1 million. The R1 million, the loan amount, you receive immediately at present. So that is what the P value is for. So the P formula, the present value formula, is very similar. It also starts with X, but then your square bracket after the X is different. Sorry, that line is a bit skew. Again, just like in the previous formula, the X is the payment that you are making every month or every quarter or however frequently they tell you in the question. X, Abby, I see you're asking, X is the payment, the monthly payment or whatever, your installment that you're making. I again appears twice, that's the interest rate, and N again is the number of payments. Now it is important that you recognize that in this formula, your exponent is actually a negative number. It's not negative in the previous one. So in the future value formula, the N is Okay, I'll do that. In the future value formula, the n is positive, and in the present value, it's negative. Okay, let me just quickly add those things. So x here in both of them is the regular payment, or you can call it an installment if you want. All right, I is the interest rate. And n is the number of payments. Okay, on the side here, I'm going to just repeat, and I'm going to write it here. The future value formula is mostly for some kind of investment where you want an amount in the future. So this is normally like a savings account or a pension account. So savings account, pension fund, basically any type of investment. So for that kind of scenario, you'll have to use the future value formula. And then the present value formula is for a loan. And there are lots of different types of loans. So we'll see when we're actually working through the questions, the different types of loans that we can identify. And we'll go through how you decide whether you're going to use the future value formula or the present value formula. Okay, because that obviously is important. If you're not using the correct formula, then you're obviously going to lose some marks there. Okay, so those are the two formulas that you learn in matric. These are new in grade 12. Other formulas from previous years that you will have to be able to use is the standard simple interest formula, which is just that. So this is for simple interest, which doesn't come up often, but you never know, it might come up, and then it's obviously good to remember that formula. This is also on the formula sheet. Yeah, it's the simple interest rate. So for this, A is your final amount, P is the amount that you invest or the amount that you borrow, I is your interest rate, and then N is the number of years. For simple interest, N will always be the number of years. It will never be months or quarters or any of that. Simple interest is just always an annual interest rate. For future value and present value, it's not simple interest, it's always compound interest. Then you need to be able to know this. Then obviously there is the compound interest formula as well, which is very similar. The only difference is that your N is the exponent of the bracket, not inside the bracket like with simple interest. And here the N is again the number of payments, not the number of years. So N is number of payments. So for example, if it's monthly, sorry, not number of payments, number of interest calculations actually, my apologies. If you are working with a monthly interest rate compounded monthly, then there will be 12 compoundings or 12 interest calculations per year. So you will then take your number of years and you'll multiply it by 12. We are going to do some examples on this, so then it should be clearer once we do that. And this is the compound interest rate. Okay, so those are your compound growth or simple and compound growth formulas. You can apply it to other scenarios. It's not always finance. It can be something like population growth or inflation rate. Yeah, you'll have to just look at the question, and if it is something where there is a kind of growth, then you might have to use one of these formulas. The other thing that could come up is depreciation or decay. So when you are buying a vehicle, for example, the value of the vehicle declines after or decreases after some time. So for that, it will be the same as the first two formulas, the same as the simple and the compound interest formulas, but instead of a plus, you're going to have a minus. So that is what we call the simple depreciation, and then the compound depreciation one. Oh, sorry, not a plus. a minus, there we go, 1 minus I to the power of n. Now, in the case of depreciation, they don't call them simple and compound depreciation. This one is always called straight line depreciation. And this is called reducing balance depreciation. Okay, so you do have to know the terminology there, because if they're talking about reducing balance depreciation, you need to know that it's going to be this formula. Okay, those are the formulas that we're going to be working with today. I think we should get going on the first paper, and then I will obviously explain as we go along. So what I have here, and I think I will also just post the document with these questions, because I copied and pasted all the finance questions into one document. I will post this on my Google Drive, and I will also post, I'll scan the note and all the solutions that I'm doing. I'll scan that in and I'll put that on my Google Drive page as well. I'll put a link in my bio. Tomorrow, I should be able to do it tomorrow. I'm also going to post this recording to my YouTube channel, and the link to my YouTube is on in my bio as well, so you can find it there. All right, so we'll start with the 2021 and then we'll work our way backwards. What I noticed when I was working through these questions myself just beforehand was that something that they're asking, or that they asked last year in 2020, that only counted 4 marks. They asked the exact same question with different values, but the same method. You had to do the exact same thing in 2017, I think, and it counted 6 marks. So it does seem like they are getting more strict with their mark allocation. It looks like they are awarding less marks for the same amount of work. So I think it would be best, if you guys are working through past papers, just in general, if you work through the more recent ones first, and if you are looking at mark allocation, if you rather go with the more recent ones, because yeah, it does look like they are trying to squeeze more content into a paper. So they're asking the same types of questions, but it's counting less marks than in the past. So we do need to work on our speed when we're actually working through these questions. I am going to post some videos about time management in a maths exam later on as well. So that's still coming up. Okay, so the 2021. Question 6, I'm just going to do a heading here so that it's all organized. Sorry for my arm there. All right, so this is the DBE November 2020 paper. Let me just make my little bubble heading here. Okay, question 6.1. On 31 January 2020, Tepo made the first of his monthly deposits of 1,000 Rand into a savings account. Okay, so he's making the first payment on the 31st of January. He continues to make monthly deposits of 1,000 Rand. So they're saying monthly deposits. So immediately we need to think annuity, because he's not just investing an amount and that one amount is earning interest. He's making a deposit every single month. So this is telling us that we are working with an annuity. I'm just going to highlight that. So this is, and they're saying he's making these deposits into a savings account. Now, if it's a savings account, we're going to work with the future value formula. So right away, you know exactly which formula you need to work with. So it's an annuity, and it's going to be the future value one. So I'm just going to put in brackets here F. We're going to work with the F formula. He's making monthly deposits of 1,000 Rand. So 1,000 Rand is going to be our X value. So there we have X. So when we are using the future value formula, X is going to be 1,000. And he's making these deposits at the end of each month up until 31 January 2032. So if we're looking at that, the first payment was made on the 31st of January 2020, and the last payment was made on the 31st of January 2032. Okay, so we'll discuss now about the number of years, because there is actually a trick in this question. The interest rate was fixed at 7.5% per annum compounded monthly. All right, so that's also important. That's going to be our I value, 7.5% per annum compounded monthly. So it's a compound interest rate. 6.1.1, they're asking what will the investment be worth immediately after the last deposit. So the worth of the investment, that is the future value. That's what they're asking us for. They want to know what amount is going to be in this annuity account immediately after the last deposit. Now, I'm actually going to go back up to this note here, because the number of years and what they're telling us here, there's actually a trick to it. For both of these formulas, what's the word that I'm looking for now? These formulas work if the first payment, I'll write it on the side now, is made at the end of the first interest period. So payments made at end of So at the end of the month, for example. In this one, in this question, we're working with monthly deposits, and they are telling us that he is making a monthly deposit at the end of each month. So we are going to use this formula exactly as it is. The trick in this question, though, is if he's making monthly deposits at the end of each month, he's making his first deposit on 31 Jan 2020. That means that his last deposit of that year will be on the 31st of December. Then he will have made 12 deposits. So it's the 31st of January, then end of Feb, March, April, May, June, July, August, September, October, November, December. So those are his 12 payments. So in 2020, he's making 12 payments, but the last payment is then on the 31st of December. He is making payments every month at the end of the month up until the 31st of January. So that's actually an extra payment that he's making. His last payment is not on the 31st of December. His last payment is on the 31st of January 2032. So from 2020 to 2032, that will be 12 years. But because he's making that last payment, because it's actually 2020 to the end of 2031, and then because he's making that last payment on the 31st of January, it's going to be plus one extra month, one extra payment. Okay, I hope that makes sense. So how many payments is he actually going to make? He's actually going to make 12 times 12. So 12 payments a year for 12 years plus 1. So he's actually going to make 145 payments. And that is the trick to this question, because his last payment is not on the 31st of December of the previous year. It's actually on the 31st of January of the next year. All right, so that is important. Okay, let me just shift my page up here again. All right, so for 6.1.1, just think I need to move this a bit so that you can see. All right, 6.1.1. So what will the investment be worth immediately after the last deposit? So we're doing future value That's what they're asking us for. I'm just going to write the formula down so that we have it in front of us. But like I said, this formula is on the formula sheet. You don't have to know it off by heart. You must just be able to find it on the formula sheet and write it down. Okay, so X is the monthly payment that he's making, which they told us is 1,000. We have 1 plus. Now the interest rate is 7.5% per annum compounded monthly. So 7.5% per annum monthly. Now, some teachers teach their students to write the interest rate over 12. I prefer to do it like this. I'm going to say that 7.5% is the same as 7.5 over 100. I'm sure we all know that. But now because it's monthly, it means that this interest, this 7.5%, has to be divided into 12 calculations. So every month they're going to add a portion of this, 1/12 of this. So in order to get the interest rate that they're going to add at each calculation, you have to divide it by 12. Then if you do that, it will leave you with 7.5 over 100. Now when you are dividing by 12, that's the same as multiplying by 1 over 12. Don't worry, you won't have to do this every single time. I'm just showing you quickly where it's coming from. So then when you actually multiply those values together, you will get that. So 7.5%, the interest rate that they're telling you, you put that at the top, 7.5 over, then you just take your 100 and you multiply it by the number of months. And we'll practice that for all of them. So this is how I would write it. I would actually write 7.5 over technically 1,200, but it's the same as 1,200, which we don't really use in South Africa. We don't use that terminology, but that is how I prefer to write it. So you can see exactly it's 7.5%. So that's the 7.5 over 100 basically there, but then it is 12 times. All right, divided into 12. So I'm going to write 7.5 over 1,200. And another thing, if you want to, you could write it like this. I know that a lot of teachers prefer it in this way. So where you actually take, this is 7.5 over 100 in decimal form, and they would then put that over 12. But I prefer it like this. I think it just reads easier. So you can see it's 7.5% monthly because the 12 is there at the bottom. Okay, now our number of payments we've discussed already. It was the 12 times 12 plus 1, or you could just write 145 straight away if you wanted to. And that is then divided by that same interest rate. It's over I again, 7.5 over 1,200. Okay, now obviously you're going to use your calculator for this. I'm just getting mine here. Alright, so we're just going to type that into the calculator. I prefer to just open my fraction straight away and then type it into the fraction like that. So I'm going to do 1,000. Now because it's two brackets, I'm going to type my two brackets. 1 plus 7.5 over 1,200. I use my arrow to go out of the fraction. I'm going to close my bracket. I'm going to press my exponent button there. My exponent, you can type it in exactly like that, or we've already calculated it, it's 145. Then I want to get out of my exponent, so I'm going to press the arrow button again, -1, and I'm going to close my bracket like that. I'm going to press my arrow button to go to the denominator, and again I'm going to type 7.5 over 1,200 equals, and then I'm going to get that 234,888.53. Okay, like that. All right, 6.1.2. I'm just going to put the number here. Okay, I went to check the memo that was posted by the department. So I just want to show you guys actually what you would be getting marks for here exactly. This question was out of 4 marks. So it was 1 mark for using the correct formula. So for using the future value formula, you get a mark. Then it was 1 mark for putting your I value incorrectly. It was 1 mark for the 145 over there, and then it was 1 mark for the final answer. So that was out of 4. All right, I did go and check all the answers on the official memos that they used to mark last year, and that was the mark allocation there. All right, then 6.1.2. Let me see, where are these questions? 6.1.2. Okay, if he makes no further payments but leaves the money in the account, how much money will be in the account on 31 January 2033? So this is now exactly 1 year later. They're saying he makes no further payments. All right, so that means that this is now no longer an annuity. It was an annuity all the way to the 31st of Jan 2032, but now he's just leaving the money in the account. Now what happens when your money is in a savings account is that it earns interest. So now we're just going to use our compound interest formula, and what we're going to do is we're going to add 12 months, 1 year. We're going to add 12 months worth of interest to the answer that we got in 6.1.1. All right, so this is now no longer an annuity. We're going to use our A equals P bracket 1 plus I to the power of n formula. Okay, and our P value now, which is like the investment, we can almost imagine as if he's taken this money out of his account and invested it again. That's basically what is happening there. So this is now the P value, the amount that was in that account, 0.53, and now it is just going to earn a year's worth of interest. It's still 7.5% compounded monthly, and the number of interest calculations now is 12, because it's for 1 year, 12 months in that 1 year. So again, we're just going to use the calculator, type that in. So we're going to have 234,888.53 bracket 1 plus 7.5 over 1200 to the power of 12, because it's just 1 year and there are 12 months in a year. We get that answer 253,123.54. Let's round that to 54. For finance, you always have to round to 2 decimals, even if they don't say anything, because that's how money works. All right, we always round to 2 cents. So we're going to have 253,123.54. Okay, and that is the amount that is in the account exactly 1 year after his last payment. Okay, this question was out of, let me just check, out of 2 only. So it was 1 mark for substituting everything correctly into that formula, and then 1 mark for getting to the answer. Okay, 6.2. I'll just turn my page here. There we go. 6.2. Jim bought a new car for 250,000 Rand. The value of the car depreciated at a rate of, is that 22% per annum? That's quite hectic, but it is like that in real life. 22% per annum annually according to the reducing balance method. Now, reducing balance is the compound one. So you're going to have to use compound depreciation, that formula. After how many years will its book value be? 92, All right, so they've given us the original amount, the amount that the car was when it was bought, and now they're giving us the book value. Now, the original value of the car is always P, and then the depreciated value, the book value of the car, is A. All right, so we're going to use the compound depreciation formula. P is going to be 250,000 and A is 92. And this is going to be our interest rate. Now, this is quite nice because they're saying 22% per annum annually. So that means that it's just going to be 22 over 100, 22%. We don't have to still worry about that denominator. Okay, so 6.2. It is good to actually just write the formula down before you start substituting things into it. So 1 minus I to the power of n, it's a minus because it's depreciating now, so sorry about that. So the value of the car is going to decrease. So we get our original, oh sorry, they actually gave us the A value. I'm so used to just subbing stuff in like that. So the A value here was 92,537,64 equal to, the original amount of the car is 250,000. Then 1 minus, interest rate is 22% annually. That's why it's just 22 over 100. And then the number of years is what they're asking us for. So that's to the power of n. So we're going to have to find that exponent. Okay, let me just move this a bit so that that's all on screen. If the comments are bothering you, you can just swipe to the left and then all the comments will disappear. Then you can just see the whole screen. Because if the comments are on, you might not be able to see the bottom part. Okay, now we need to solve for n. So this is now just like a normal equation. We have a certain order in which we need to do things. First, we're going to divide that by 250,000. Let's do that first. So we have 92,537.64 divided by, you can also just use the division button, that's perfectly fine, 250,000. All right, so that is 0.37. Now it is very important, guys, that you don't round that off. Okay, you can write down a rounded value if you want, but I'm actually going to do this as a reminder that we are not allowed to round that off. It's not our final answer. We can only round off our final answer at the end. So we need to keep working with this whole value. So that is then equal to, because I've now moved this 250,000, I'm just going to be left with this bracket. And we can actually work that out if we want to. I just want to show you guys quickly, if you now want to use your calculator to calculate this, but then obviously you're going to have to clear this, then you can't use the answer button for this. You would want to store this value. So in order to store a value on the calculator, if you have the Casio one, it doesn't have to be the silver one, it can be any of them. You would press Shift, and then if you look at the RCL button, it says STO above it. So you're going to press that. That is the store button. And now you have a row of buttons here that have letters above them. And even there, you also have an X and a Y and an M. You can just press any of those buttons. I'm choosing to save it as A, so I'm going to press that button. And now the answer has been saved as A. So now if I want to use this value again, I'll show you. You're just going to have to press alpha and then A, and then the calculator will use this exact value, which is very useful. All right, now this you can just do in your head. It's 1 minus 0.22, which is 0.78, but you can also obviously type it into the calculator and you'll get 39 over 50. If you press the SD button, it will give you the decimal one, which is 0.78. So I'm actually just going to write it as 0.78 there, just because it's quicker to write than 1 minus 22 over 100. But you can also keep writing 1 minus 22 over 100, that's fine. Now here, we need to make n the subject of the formula. We need to solve for the exponent. And in order to do that, we're going to have to use logs. Now, when we use logs, the base of the exponent is going to become the base of the log. The exponent is going to become the subject. And then the other number is going to be after the log. So it's going to look like this. The exponent now becomes a subject, so n is equal to, then you do log. Now the base of the log, so the number here that's in the subscript, is going to be the same as the base of the exponent. So it's going to be 0.78 over there. And then the last number, which was this one that we saved on the calculator, is the last number for the log there. So when we are typing it into the calculator, you are going to use this button. You're going to press it. There you see there's a space for you to type in the base. The base was 0.78. And now we need to use this number. We're not allowed to just type 0.37. It has to be the unrounded value. So we're going to press alpha. And we're going to go to the A button. We're going to press A. And it's going to use that saved unrounded value, equals, and there we get our answer. N is 4. So 4 years, because N was years in this case. Okay, this question was only for 3 marks. So it was a mark for substituting everything into the formula there, then a mark for using logs, for actually showing that you're using it, and then a mark for your final answer. So 3 marks. All right, we're nearly done with the first paper stuff. We only have 6.3 to do still. All right, so 6.3. Mpho is granted a loan under the following conditions. Now here, loan, so we need to think we're either going to use our, what's it called, our compound or simple interest rate formula if it's just a straightforward loan that's paid back in one amount at the end of the period, or if it's monthly payments, or if if Mpho is paying, paying it back over time, then we're going to have to use for loan the present value formula. So they're saying the interest rate is 11.3% per annum compounded monthly. So I'm going to write that as 11.3 over 1200 because it's monthly. There are 12 months in a year. So like that. The period of the loan is 6 years. The monthly repayment, so there we see monthly repayment. She is making monthly payments. So we're going to use the present value formula for this because it's a loan that's being repaid in regular installments, regular repayments. So the monthly repayment on the loan is 1,500 Rand. Her first repayment is made 1 month after the loan is granted. So that's perfect. It's made 1 month after, so it's made at the end of the first month. That's correct. That means that we can use the present value formula. 6.3.1, calculate the value of the loan. All right, they didn't actually tell us how much money Mpho is loaning. All right, so we need to calculate what the value of the loan is. We need to find the P value, essentially. Okay, so that's quite straightforward. We're just going to use the present value formula. So 6.3.1, I'm just going to write the formula down. Again, this formula is on the formula sheet. You just need to be able to identify which one you must use. Okay, we're going to find P, so we must just sub everything else in. They've given us all the information that we need. X, the monthly repayment amount, that is 1,500. That was given, they told us that. 1 plus I, the interest rate, was 11.3% compounded monthly, so it's over 1,200. And now to the power of negative, remember for this formula the N is negative. Now N is the number of repayments. So Mpho is paying for 6 years every month. So it's going to be 12 times 6. Or you can write 72 straight away if you know that 12 times 6 is 72. And then that again is over I, the interest rate, which again is 11.3 over 1,200. All right, and now we must just type that into the calculator and then we're done. So we have 1,500 bracket, 1 minus another bracket, 1 plus 11.3 over 1,200. Use the arrow to get out to the power of negative 72. Or you can type negative 12 times 6 as well. Now you have to close your bracket, guys, otherwise it's going to give you a syntax error. So close that bracket there. And then over 11.3 over 1,200. And that is the amount. So that is the actual amount of the loan. All right, so that is 78,173 Rand and 49 cents. Okay. Now, that was a 3-mark question. So it was, let me just check here. It was 1 mark for getting this correct, a mark specifically for that. Then it was another mark for substituting everything into the correct formula. So for using the present value formula and for subbing in the other stuff, and then 1 mark for the answer. Also 3 marks for that one. Now 6.3.2. This is a bit of a complicated question. It has many steps. So 6.3.2, they are saying how much interest will Mpho pay in total over the first 5 years. Now this loan was repaid over 6 years. So they're asking us now how much interest will she pay over the first 5 years. Now this kind of question, this is the question that I was talking about at the beginning of the live when I said that in 2020 they only gave 4 marks for this question, but I think it was 2017, it might have been 2018, they gave 6 marks for this question. So this question has lots of steps. They're very stingy with their marks for this one, and it has come up multiple times, so I think you do need to be prepared to answer this kind of question. So how much interest will she pay in total over the first 5 years? They're asking how much interest. They're not asking how much will she pay. They're asking how much of what she is paying is actually interest, as opposed to the loan that is being paid back. Because when you take a loan out, they charge you interest, and when you are making your payments every month, those payments will include a portion of the actual loan that you're paying back. So a portion of the 78,000 Rand, and then the rest will actually be interest. So they're asking us over the first 5 years, how much of what she's paying is interest. All right, so I'm going to write down the steps for this kind of question. So for how much interest, the first thing that you're going to do is you're going to get the balance on the loan, how much she actually still owes after 5 years. So balance on loan after 5 years. So that's the first step. The second step, and I'll show you the formula that I use for that. There are 2 formulas. I prefer one of them, and I'll explain why. The second step would be to then take your loan minus the balance. That will give you the capital amount that is paid off. Okay, once you have that, your third step is going to be to calculate how much she actually paid. We know the monthly payments are 1,500 Rand. We can calculate how much Mpho has paid after 5 years in total. And we know that that amount that she's paid includes capital and interest. All right, so the third step is going to take your monthly payment multiplied by the number of months and that is equal to actual amount paid. Now, when you know how much she's paid, step 3, and you then minus the amount of that was actually the loan, the capital amount, then what you're left with is your interest. So that will be your final step. Interest is then actually your actual amount paid minus, let me just move that down a bit, minus your capital amount paid. Okay, so it's quite hectic. It's a lot of work for only 4 marks. And I did check the memo. There isn't a faster way of doing this. This is the only way of doing it. I did this at first when I read the question, and I was thinking the whole time, I can't think that they would only give 4 marks for this. It's so much work. But then I did go and I double checked, and yeah, it is 4 marks for all of this. Now, we can put this all together in two calculations. So the two calculations is going to be to find the balance on loan. All right, you're going to do that as a separate calculation, but then all of this we can actually do in one line, and that will then help with, you know, rounding. You're not going to have to save a whole bunch of values, so I'll show you how to do that. But it is good if you understand where all these values are coming from, because they could also ask you to do them separately. And then at the end, they can ask you to compile it all together. So, okay, 6.3.2. How are we going to start this off? We need to find the balance on the loan after 5 years. All right, so I'm just going to move this down. So, step 1. Balance after 5 years. Now, this formula is not on the formula sheet. This is one that you have to memorize. You have to remember this formula. And there are actually two ways in which you can do it. I prefer the slightly longer way because it requires less thinking. So that method is by saying that you're going to take your loan amount, which is P, your present value that we calculated in the previous question, and you're going to add interest for 5 years. All right. Then from that, you're going to minus the future value of all the payments that you have made in those first 5 months. Well, not you, actually, I'm Paul. And what you're left with, the difference between the two, is then what you're actually owing. Now, where this formula comes from, it's as if you are looking at your annuity as two separate things. So you're almost saying that the loan amount is a loan that you will pay back at the end of the 5 years, for example. It's not, but we're just pretending that it is with this portion of the formula. Then, of course, we are making monthly payments. So the monthly payments we are seeing almost as a separate investment. And then we're saying if you take the loan and what you would owe on that loan after 5 years, but then you minus the value of all of those monthly payments and the interest on those monthly payments, the difference between those two would actually give you the balance on the loan. Now, I'll show you the other formula just now, and you should get the same answer or a very similar answer. But what you're going to do for this formula, our answer for 6.3.1 was P. So I'm going to use that as the loan amount. So we have 78,173.49, bracket 1 plus. The interest rate was 11.3 over 1,200. Now they're looking for the balance after 5 years. So that's what we're going to use for our N. Because it's monthly, we're going to say 12 times, and the number of years then is 5. Because that's what they're asking for. They're asking for the balance after 5 years. Minus. Now we're going to use the future value formula, with the payments that we've made. So we're going to say 1,500, that was X. We're going to do 1 plus 11.3 over 1,200. Again, our N is after 5 years, 12 months a year times 5, then minus 1, and that is all over I, which is 11.3 over 1,200. And we're going to type all of this into the calculator, which is going to take quite long, but I'll just do it quickly. Oh, 173.4, oh, sorry, I'm losing it a bit, 0.49. Then we do our bracket, 1 plus 11.3 over 1,200 to the power of 12 times 5 is 60, but you can type in 12 times 5, that's fine, minus, I'm going to do my fraction for this bit, 1,500, bracket, 1 plus 11.3 over 1,200, close bracket to the power of 60, minus 1, I'm going to close that outer bracket, and that is again over 11.3 over 1,200, and there we go, and that is the balance after 5 years. Now, because it's a 0, 0, 0, and then a 6, we can just round this to 16,945. So that is what Mpho owes after 5 years. All right. Now, the other formula for balance on a loan is if you take the present value of the payments that she still has to make. So you're going to use, let me just write it here. Now, the present value formula, remember, is this one. All right. But we're going to do the present value of the payments that I still, or that Paul still has to make. Now, this is a 6-year loan. They're asking for the balance after 5 years. So this N that we're going to have here is going to have to be for 1 year. That's why I'm saying the first formula is longer, but it's almost less thinking, because you're just going to use, if they're asking for the balance after 5 years, you just use 5 in your exponent. If you use the present value formula for the balance, you have to do the years that are remaining. Now, it's not necessarily difficult. It can become a bit complicated sometimes. In this case, it's quite easy because it's a 6-year loan. They're asking for the balance after 5 years. So we're going to do 6 minus 5, and we're left with 1 year. So our exponent there is going to be 12 times 1. But that's just something that you have to remember to do then if you want to use this formula. But it's fine. We can use it so that you see both of them. So again, you're going to use the monthly payment, which is 1,500, 1 minus, and then 1 plus. The interest rate again is 11.3 over 1,200 to the power of negative 12 times 1. That's the number of years that are remaining. You can just write negative 12 also, that's fine. And that is then over 11.3 over 1,200. Now, we might get a slightly different answer because this, no, it's fine. We'll get, because here, the value that we used in the previous method, we used a rounded value from 6.3.1. So that might mean that here we might get a slightly different answer, but it's fine. It might differ by a few cents, but you can leave it like that. It's okay. It doesn't matter. So we're doing 1 minus, and then our bracket there, 1 plus 11.3, sorry, that's off screen, over 1,200 to the power of negative 12. And that is then divided by 11.3 over 1,200. And we get, so it's going to be comma 01, which is also fine. It doesn't matter. You can use either of these methods, both answers. They do always have, and I did check the memo, like I said already, they had both options on the memo. So you won't lose marks for using a specific method. Both are fine. Okay, so that was now a very long explanation for the first step of this question. We found the balance on loan after 5 years. Now we need to take, in order to find the capital amount that she's paid off, we need to take the actual loan, which was this, 78,000, and we need to minus the balance on the loan. That amount is then how much of the actual loan she has paid off. And that we must minus from the actual amount paid. So from here on, we're actually going to do it all in one step. We're going to write interest equals, for our actual amount paid, how are we going to find that? She paid 1,500 Rand every month for 5 years. So we're going to take 1,500 times 60. 5 times 12, there's 60 months in 5 years. That will give us the actual amount paid. Then we're going to minus the actual loan, we'll put it in brackets, the actual loan minus the balance on the loan. So we can do all of this now in one line instead of doing a separate calculation for every single step. So I just need to turn the page quickly. Run out of space. Let me also just move this camera up a bit. Okay. So I'm going to write the formula down now as we're going to use it. So interest is equal to, you don't have to write this formula, but maybe just write it down now so that you have it as a formula that you can perhaps memorize. So the interest is going to be X, which is the monthly payment, multiplied by number of months. Then from that, we are going to subtract the loan minus the balance after, just move this up a bit, balance after 5 years. Okay, it's just a bit less writing than actually writing the separate steps like I wrote them down earlier. So the X amount, the monthly payment was 1,500. The number of months is 60, but remember we got that from 5 years and 12 months a year. And this is what they're asking for. They're asking how much interest did she pay in the first 5 years. So that's why I'm using 5 here and not 6. The entire loan is paid off in 6 years, but they asked for in 5 years. So that's why we're using a 5 here. Minus the loan was, let's just go back to the previous page quickly. Sorry. 78,173.49. I hope that's correct. Let me just check. I made a mistake. 173. 78,173. Let me just fix that. There we go. Minus the balance, which was 16,945. All right, now we don't have to worry about rounding off issues. It's just this, which we would have had to work with the unrounded value, but luckily it was a nice answer for this one. Okay, so we're going to do this. 1,500 times 5 times 12. Oops. Close bracket. Minus loan minus the balance on the loan. And there we have the amount of interest was 28,771 Rand and 51 cents. All right. And that is the final answer. Like I said, this was a 4-mark question, which I think is quite strict. It's quite stingy with the marks. So what you got the marks for was it was 2 marks for calculating the balance. All right, so it was 1 mark for subbing everything in and then 1 mark for getting that value, which we did on the previous page. So that was 2 marks. Then it was the 3rd mark for saying this amount, which was actually 90,000, and for subtracting this. So basically for having this kind of formula there, and then 1 mark for the answer. Okay, so I suggest that you remember this formula. Like I said, they've asked it multiple times before, so I think it's good if you actually remember this. Okay, grade 12s, we have run out of time. We've done the 2021. I think what I'm going to do is I will record a YouTube video tomorrow of me working through the 2019, 2018, and 2017 finance questions, and I will post all the answers along with the actual questions on my Google Drive, and I will put a link to that in my bio. Yeah, I hope that was helpful. I hope that you learned something. Let me know if you have any requests for other topics that I should work through. The next one that I am definitely going to do is trig. That will be next weekend. And then I hope there is another weekend after that for me to do some Euclidean geometry. But there are loads of videos on my YouTube channel. When am I teaching cubic functions? It's not on my list, but thank you. That's noted that you guys would like that topic. Yeah, you can just comment on any of my videos if you would, or you can send a Q&A if you would like any other specific functions or specific topics rather, and I will let you guys know when I will be doing that. Next weekend we could do a longer session, not only an hour, we could possibly do a 2-hour session. And also let me know what time would suit you guys best. I know a Sunday is a bit difficult, but yeah, I would like to help as many people as possible. But everything is on my YouTube. All my notes are on my Google Drive. Please make use of those if you need them. And yeah, let me know if you guys need anything else. Especially with the formulas, how to get the equation when you have to do simultaneously. Yes, okay, yeah, those are difficult questions. Cool, I will add that to my list. Thank you for that suggestion. Thanks so much, guys. I hope you enjoy the rest of your Sunday. Thanks.